Hello everyone, welcome to my talk. Today I'm going to introduce our web conference paper, Cooperative Memory Network for Personalized Task-Oriented Dialog Systems with Incomplete User Profiles. This work is done by me, Jiahuan Pei, with Peng Jieren and Martin Dreik. This work is a cooperation work with University of Amsterdam and Shandong University. Here is the overview of this talk. First, we'll start with a brief introduction, including the motivation, why to do this work, and how to formulate the task and what are research questions we are focusing in this work. Next, we will go deeper to the model details, including the architecture, dynamic pipeline, multiple hop variant, and how to design the laws to train it more effectively. And third, we'll introduce how to use the datasets and how to evaluate models. Next, we'll see the main results and the analysis. Finally, we summarize some takeaway messages as a conclusion. Intuitively, user profiles are usually incomplete with lots of missing values. For one hand, not everyone is willing to expose their profiles due to the privacy concerns. Or on the other hand, user profiles involves too many aspects, which makes it impossible to collect for all this information. And our question is it possible to conduct a personalized dialogues with incomplete user profiles in this cooperative paradigm? Just as it shows in the figure, dialogue helps to enrich user profiles gradually, and user profiles improve the dialogue vice versa. Then let's formulate our task. Then we formulate the task as personalized TDS with incomplete user profiles. So given the dialog context as input, which consists of a user profile, dialog history, and the current user utterances, our goal is to select an appropriate response from the candidate sets as an output. So please note that here, the user profile is an incomplete one because it is impossible to eliminate all the candidate values in the user profile. And we are focusing these three research questions. First, how well does the CoMemNN perform? Does it significantly and continuously outperform the state-of-art models? And second, what are the effects of these components in the CoMemNN? And third, does different user profile attributes contribute differently? Next section, let's go deeper to the model details. Here is the architecture, consists of two cooperative modules. That is the user profile enrichment module and the dialog response selection module. And we'll start from the bottom part. For each turn, given dialog context, which consists of a user profile, a dialog history, and current utterances. And the UPE module works with memory initialization, memory updating, and memory reading process respectively to get an enriched user profile. And this user profile can be used to improve the DRS module and select the better response. Here is the dynamic pipeline. For each turn, the model runs in the following steps. First, MI embeds the user profile relations into profile memory. And it embeds the user dialog relations into dialog memory, and also embed the current user utterance into query memory. Next, MU uses query memory to address the profile memory and dialog memory respectively to get to intermediate memory here. And use this to intermediate memory, we can get an enriched profile memory. which consider both the user profile and also the user dialog. After that, MR use query memory to raise the localized memory slot for the dialog part and for the user profile part. After that, these two information is used to update the previous query. Last, the DRS used the updated query to match and select the best candidates as a correct response. After that, we explore the multiple hope setting of the model. The stack of the hopes is from line 4 to line 9, and it executes this MU module and MR module for hopes n times. So in the end, we'll get two distributions. One is the dialog response distribution at line 11, and the other one is the profile enrichment distribution at 13. To optimize the DRS, we use the standardized cross entropy loss of the dialog response selection task. And to control the user profile enrichment loss, we introduced the element-wise mean square loss between the sampled P and its corresponding enriched profile delta P. And the final loss is a linear combination. For dataset, we use the personalized Bobby dialog dataset with a small and large version. This is only dataset for personalized TDS and not available for our incomplete profile setting. So we simulate the incomplete profile with various of degrees, randomly discuss some values in user profiles with the probability from 0 to 100%. For evaluation, we consider both performance and stability. For the former, we evaluated by the accuracy of dialog response selection task and profile enrichment task. And we evaluate the latter by a coefficient sigma. This is the standardized deviation of a list of a performance. This performance could be the RSA or PEA. Great. Let's see the main results. Without discussing the user profiles, we compare the results of CoMemNN with the 4 reported baselines and 1 re-implemented SOTA baseline. From the results, we can see that CoMemNN outperforms all baselines on both the small and large datasets by a large margin. This means CoMemNN can enrich actual information, and this is really helpful with the performance. Next, we discuss user profiles by various extent and compare the results with the SOTA baseline. And we found that first, the CoMemNN significantly outperformed the SOTA baseline on both datasets. The CoMemNN steadily decreases with the increase of profile discard ratio increase because with discussing more information, the model can not work very well at that case. For stability, the SOTA baseline has higher deviations and the proposed CoMem model is more stable. So why does CoMem work? We have done ablation study on profile enrichment accuracy and response selection accuracy respectively. For profile enrichment accuracy, we can see that first, CoMem can effectively enrich user profiles by inferring the missing values. Because we can see the prediction results is very well. And second, we can see that for each component of the UPE generally has a positive effect on the performance, since most of the PEA will decreases when we remove these components. For response selection accuracy, we can see that first, The performance decreases generally by removing any component of a UPE. And second, we observe that for information resources, that is neighbor profile, current profile, neighbor dialog, and current dialog, um, have different effects under different profile discard ratios, and they are complementary for good performance. After that, we also studied the effect of different profile attributes and found that each attribute works well in isolation. Here we can see the results in this line. This means only remain one of the attributes. And second, we observe that different type of attributes depend on each other differently. So they are complementary for each other. To conclude, we have three contributions in this work. First, we propose a novel practical task that is personalized task-oriented dialog system with incomplete user profiles. And second, we propose a novel model CoMemNN with cooperative interactive modules, which can enrich user profiles gradually as the dialog goes on, and to promote the response selection based on the enriched profile simultaneously. Last but not least, the extensive experiments has proved that CoMemNN significantly outperformed the state-art baselines and especially works very well in incomplete user profile settings. The limitation of this work is that we only test the command model on one dataset because we cannot find out other datasets working on this scenario. And for future work, we're thinking about to do some experiments on more datasets and explore whether it is possible to improve the performance by leveraging the non-personalized TDS datasets. Thanks for your attention. We have released our updated paper and code, so feel free to use it and contact me by email if you're interested in this work. Thanks.